Okay, we're going to take a look at solving quadratic equations by factoring. Now remember that the word quadratic here, right, that just means that we have an x squared or a y squared or an a squared. Okay, now one of the things we'll have to notice about this chapter, this is very different than the linear equations we solved earlier. Right, when there were no exponents and just variables, we moved all the variables to one side, all the numbers to the other. But once we start seeing exponents like this, that's not going to work. Okay, so we're going to start off with a basic idea here that's very important, that kind of drives the whole section. And this first question here, what do we know about a and b if a times b equals 0? Right? Well, one of the nice things about 0 is anything times 0 is 0. Right? We all probably remember that. But the other thing that we don't always necessarily think about is that if two numbers multiply to 0, then one of them must be 0. Right? You can't take two numbers that are not 0, multiply them, and expect to get 0. So if a times b equals 0, right, then we know that either a is 0 or b is 0, right? Or in theory both, right? But if a is 0 and b is 0, then you got your bases covered here, okay? So this is going to be the thing that kind of drives this whole section, right? 0 being the key here, right? One little side note, if two numbers multiply to 4, we don't know anything about them, right? It could be 4 times 1, it could be 2 times 2, it could be a half times 8. So really the 0 is key. Now in this first video, we're going to already have 0 in the equation, okay? And the next step in the next video would be when we don't have 0. Well, we'll just have to make a 0 in order to use this technique. Okay, so what does this a times b equals 0 up here have to do with quadratics? Well, we just spent a good amount of time learning how to factor quadratics. So if we had an equation that ended up with this, right, x minus 2 parentheses, right, times parentheses x plus 5 equals 0, we basically have two things, right, a times b equals 0. Okay. So what did we say? Well, either the first one could be 0 or the second one could be 0. Okay, so if we look over here, we have a times b equals 0. What do we know? We know that either this first one equals 0 or this second one equals 0. Okay? So if you get to the point in the problem where you have two things multiplied to 0, you know that either the first one could equal 0 or the second one could equal 0. Well, these are both very easy linear equations to solve. Add, in this case, add 2 to both sides. Right, and we get x equals 2. For this one over here, we can subtract 5 from both sides. Right, 0 minus 5 is negative 5. So we get two answers. Okay, the two solutions to this problem are x equals 2 and x equals minus 5. Okay, now this is again a big change from what we're used to solving. We're used to solving linear equations where we just have x's and we just got one answer. Behind all of these is going to be this x squared up here, right? So because it's an x squared, we might have two answers. Okay. So our goal is going to be to get down to this step. Right? This step is sort of the new material. If you have two things here multiplied to 0, then you know the first one could be 0 or the second one could be 0. Solve those as two independent problems. Right? They are both easy linear equations. Just get the x's to one side, numbers to the other. There's no more squareds at this point. And then we can finish. Okay, and you should expect to have two answers. It's possible that both answers are the same. All right, we'll deal with that maybe in some special cases, but this is the basic idea. Okay, so now you might be wondering, what does this have to do with x squareds? Well, think about where this would have come from, right? This is one of those trinomials that factors. So let's say we start with a problem like this. X squared minus 5x plus 6 equals 0. Okay, so in a case like this, before we try to get x, we're going to try to factor first. So we're not going to try to just bring all the x's to one side and all the numbers to the other, right? We're going to do what we've just been doing for the past few classes, try to factor this x squared part, factor the left-hand side. Right? Factoring takes something and writes it as a multiply. So if we can write two things multiplied to 0, then we can do that last step. Right? This is one of those trinomials. We need to find two numbers, right, that multiply to 6, and those same two numbers are going to have to add to -5. Okay? 3 and 2 work, right? But they both have to be negative, right? So this becomes, as we've done at least, a few times, x minus 2, x minus 3 equals 0, right? So the 0 is just coming down, right? But what we did here is we factored this using whatever factoring technique applies. So everything you did up till now in chapter 4 is going to take care of the left-hand side, factoring. Now, in this case, it factored as a trinomial. In some cases, it'll be a GCF. Some cases, it'll be a difference of squares. So getting from this first line to the second line over here is going to use all the factoring techniques. The new material that we just learned was, okay, now we have two things multiplied to 0. So either the first one 0 or the second one 0. Okay? Again, these are both sort of one-step linear equations to solve. Add 2 to both sides, and we get x equals 2. Okay. Add 3 to both sides over here, and we get x equals 3. Okay, so there are two answers to this problem, okay, 2 and 3. And if we did the right work, there's not really any reason to check. You don't have to check, but it's not a bad idea to sort of check and understand what's really going on here. So off to the side here, I'll try to keep this all on one screen. I'm going to check my answer. I'm just going to check x equals 2, and then you could try checking x equals 3. Okay, we are claiming, right, and hoping, because we did the work right, that x equals 2 makes this original equation equal to 0. So let's plug 2 in. 2 squared minus 5 times 2 plus 6 should equal 0, right? I just took the x equals 2 here and put it into these x's. Okay. Well, what's 2 squared? That's 4. 5 times 2 is 10, so 4 minus 10 plus 6 should equal 0, right? 4 minus 10 is -6. And what happens if you add -6 plus 6? You get 0, right? And that's our check that it worked. Okay, so when we solve one of these equations, just like any time we solve an equation, you should be able to plug that value in. Now the thing to understand is you have to put the x equals 2 now into two different x's. You don't put the x equals 2 here and the x equals 3 here. You do it once for 2 in both x's, once for 3 in both x's. Those are the only two numbers you could plug into x to turn this into 0. Okay, this is sort of a big thing to sort of take a step back from and understand what we're doing. When we're solving a quadratic equals 0, we're going to try to do it by factoring. There are other techniques you'll learn in other courses, but for this semester we're just going to do it by factoring. So what we're going to do, we have the 0, we have to factor what's on the left. You have 4 factoring techniques. Usually it's just going to be GCF, difference of squares, or trinomials. In this case it was the trinomials. So we went off to the side, did the work to factor, right, and then set each of those factors equal to 0. The checking is optional. Okay, so let's do a couple more together here. If you want to try these on your own first and then see the solutions, you can pause it, or you can pause it at any time. But I'm going to start with this first one. Now the first two up here, if you notice, they're already factored. Okay, now if you sort of forget about that and get thrown off by it, sometimes people multiply these out, then repeat all the work just to get it back to where it started with. We often give you a few, especially at the beginning where they're already factored, just so you can see the basic idea, right? You already have two things multiplied to 0, so either the first one equals 0 or the second one equals 0. So we have, let's see if I can do this, a minus 4 equals 0. Just still having trouble. I'll try to figure out a better pen solution here. And then we have a plus 7 equals 0. Okay, so what do? We add 4 to both sides, add 4 to both sides. We get A equals 4. That's one answer. Okay, subtract 7 from both sides. Right, 0 minus 7 is negative 7, so we get A equals negative 7. Okay, so in this case, you don't have to know any factoring. They've already been factored for us. We just have to know the new material in section 4.6 here, which is to take it one step further and solve. Okay. This next example, right, there's really two things here being multiplied to 0. Right, these are the two things here. So either the first one equals 0, 3x equals 0, or the second one equals 0, x plus 5 equals 0. Okay, again, this one's already factored for us. Now, this first one may look a little bit different, right, because it's not an x plus something, it's a 3 times x. So how do we solve for x? We divide by 3 on both sides, and we get x equals 0, right? 0 is a perfectly fine answer. Okay. On this one, we're going to subtract 5 on both sides, and we're going to get x equals negative 5. Okay, so again, it's already factored for us. We have our two answers. Okay, so that's the new material. The new material is once you have a factored quadratic, can you set each of the factors equal to 0? That's actually the easiest part of this whole process. The hardest part is still going to be in the problems like these here, where we don't have the factoring done for us. But again, this is stuff that we've been doing for the last week or so, even longer, factoring these. Okay, when you look at this one, there's no GCF, right? It's not a difference of squares, so we're going to have to look for the trinomial pattern. We need two numbers that multiply to 12. Those same two numbers are going to have to add to 8, right? And if you don't see the numbers right away, then you start sort of systematically 1 times 12, 2 times 6, 3 times 4. If it's going to factor, one of these is going to have to work. The 2 and the 6 are going to work, so we'll fill in a 2 and a 6 and a 2 and a 6. We don't have any sign issues to worry about, right? So this one here becomes, right, x plus 2, right, x plus 6. I'm just going to run out of space here again because of my, pen issue. Okay, and that is going to equal 0. Okay, so this 0 comes down. It's still an equation, right? We had x plus 2, x plus 6. So now what we're going to do is we're going to solve each of these independently. X plus 2 equals 0. X plus 6 equals 0. Okay, subtract 2 on both sides. Subtract 6 on both sides. Again, this is sort of the easy part. We get x equals negative 2, and we get x equals negative 6. Okay, two answers, negative 2 and negative 6. If you're not sure that they're right, go ahead and plug them in. Plug in a negative 2 here for x, here for x, right? Square the first one, multiply the second one, add 12, and make sure you get 0. Okay, so this first one required, it was a trinomial, it required doing the blanks over here, right, which sometimes requires doing this work, but once you get the blanks, you can then factor it, right? We have it factored over here. Once it's factored, you can split those factors apart. Okay, this second problem here, right, b squared minus 49 equals 0, there's no GCF, right? We always start factoring with that question. It's a difference of squares. It's an a squared minus b squared, right? So we're going to get two parentheses with the same things inside, one plus and one minus. It doesn't matter whether you have the plus first or the minus first. So we have b times b, right? To get b squared, we have 7 times 7 to get the 49. Okay, so again, now we've done the hard part. The old material was the factoring. We factored b squared minus 49, right, into b plus 7 times b minus 7. Now we have to set each of these factors equal to 0. So b plus 7 equals 0, b minus 7 equals 0. How do we finish? Right? Well, we just subtract 7 on both sides here to get b equals negative 7. That's one answer. We add 7 to both sides over here to get b equals positive 7, and that's your other answer. Okay? And hopefully you could see on this one to check, right? If you put b squared in as either positive 7 or negative 7, you're going to end up with a positive 49, and 49 minus 49 equals 0. Okay, so these are the types of problems that you're going to be seeing in the homework and on a quiz. Some of them will be already factored, some of them won't be. The only new material is taking the factored step and splitting the two factors and solving them separately as two separate equations equals 0. Okay? The hard part is still going to be the factoring. Can you do the trinomials? Can you do the difference of squares? Can you do a greatest common factor? And eventually you might have to do both. You might first take a GCF out and then do another factoring technique. But right now we're going to keep it simple for the first set of problems.